Hi, this is Dr. John Bergdorf, and this is the fourth video in my series on rigid motions, transformations of objects in the plane that preserve both shape and size. From the very beginning, I mentioned that there were three rigid motions that counted for sure: translation, rotation, and reflection. And we've looked at all of those. Sometimes a fourth one is mentioned. It is actually a combination of two of the others. And so it is not always considered to be one of the rigid motions. It's just a combination of two others. This final, but I'm going to do a video on it anyway, because it is often mentioned. It's called glide reflection. And what it simply means is that you're going to take an object, and here I have my triangle spike that we've looked at before. We're going to translate it according to a translation vector. Here I call it a glide arrow. That's just another term that's used often when we're in this context. We're going to first translate it in that direction. Then we're going to reflect it over a line of reflection that in this case we're going to call a glide mirror. Again, a different term just to get used to some different language. And actually, you'll see that what we simply do is to do two of the operations that we've seen so far, just one followed by the other. This is easiest to do with tracing paper. So I put some tracing paper over my picture, and I'm going to first of all trace spike. I'm going to do the translation first and then the reflection. That's generally what is understood to happen. Oops, didn't go far enough. Hold on. I also slid a little bit. All right, like this, like this, like this. Trace spike and trace the glide arrow. The glide arrow or translation vector or slide arrow, however you'd like to call that, tells you in which direction and in how far to move your object. And this is a good review. In order to do translation, what you do is you slide the tracing paper so that the arrow slides over itself as perfectly as it can until the tail of the copied arrow matches the head of the original arrow, all lined up in a perfectly straight line. You'll see that as you move along that arrow, spike also moves. So he moves down to here. We're going to need, this is the end of the first step, we're going to need to locate him. So I'm going to slide my template of spike underneath and line him up with this partial drawing. This is really only the first of two steps in this one. He moves to right here. Take the tracing paper away for a minute. Trace around spike. That will be the translation or glide part of our glide rotation. Like this. Oh, well, I took that away too soon, but these two ends will simply join here. Now we're going to do the reflection. We're going to reflect not the original spike, but the translated spike. And so this reflection rather, will be exactly like we've done reflection before. I'm going to use the same tracing paper. Let me just slide that up so it's not in the way. I need to trace this partway spike. So that goes like this, and like this, and like this. And I also need to trace that line of reflection, which I'm here calling a glide mirror. Again, different words for the same thing. So I need to trace this line as well. And the way we do a reflection, you'll remember from a previous video, you take your entire piece of tracing paper, you flip it over, and line up the line of reflection. And you'll now see that not only has spike been translated, he's also been reflected. So you've got a mirror image across that glide mirror, and we will now slide my template of spike underneath. That looks pretty good. Hold him still, take the tracing paper away, and trace around him. So we first did a translation followed by a reflection. Again, this is called glide reflection. You either can consider this simply two rigid motions, one following the other, or if you want to give it the dignity of its own special name, that is a glide reflection. This is the original. This is after the translation only. This is the one you really want. That's after the reflection as well. So that concludes our set of videos on the 3 or 4 rigid motions. Now, how this all ties in when we move on from basic geometry into, say, into analytic geometry in high school is we begin to explore the idea of congruence. Congruence, our two objects are congruent if one is the image of another after a single rigid motion or after a sequence of rigid motions. So for example, you might take an object, you might reflect it, rotate it, and then translate it. And the end result will be an object that has the same shape and size as the original, and we would say that that is congruent. So thank you so much for your attention to this series of videos on rigid motions.